Hello everyone. In this lesson we're going to take a look at conservation of energy. Now we know the law of conservation of energy says energy cannot be created or destroyed, it can only transform and transfer. It can move from one object to another and it can change what type of energy that it is. But we can look at a special case where mechanical energy is conserved. Now remember, mechanical energy is kinetic plus potential. So mechanical energy is equal to an object's kinetic energy plus its potential energy. Now, we have to account for all the different forms of potential and kinetic energy that it has, but if we add those up, that's mechanical energy. And in the event that nothing does work to reduce that mechanical energy, then it will stay constant. So essentially what we're going to say, if no forces do work to reduce mechanical energy, then mechanical energy is conserved. And all that means is the mechanical energy will stay the same. So if you consider a roller coaster, but the special case of a frictionless roller coaster. So a roller coaster starts here and it has some potential energy, right? Let's say it starts at rest right there. Well then, because it has some height above the ground, there is potential energy here. Now as it moves along this thing, gravity does work, but gravity doesn't reduce mechanical energy. Gravity is what we call a conservative force. Gravity converts energy between kinetic and potential. And the reason we know it does that, or why it does that, is because when this thing is moving this direction, it's moving down, gravity's pulling it down, gravity's doing positive work on it, and that's causing this thing to lose potential energy as it loses height, but gain kinetic energy because it's getting faster. So right in here, it'll have some kinetic energy and some potential energy, but those two things will add up to the potential energy we started with, because gravity's not reducing how much energy it has. Gravity is only changing the energy from kinetic to potential or potential to kinetic, right? So as it's coming down, gravity's changing potential to kinetic, and it gets down here, and again, its kinetic plus potential will add up to that, which will add up to the potential energy it had at the beginning. And then as it rolls back up the incline, it will get slower, but that's not because it's losing energy, it's because it's losing kinetic energy but gaining potential energy. So we get up here, and its kinetic energy plus its potential energy is still going to be the same. And so when mechanical energy is conserved, the sum of kinetic and potential energy is everywhere the same. That doesn't mean the kinetic energy is everywhere the same, doesn't mean the potential energy is everywhere the same. It means that if I add the two up, it stays the same. And we'll take a look at an example problem with that in a minute. Now, there's also the idea of non-conservative forces. So what happens with a non-conservative force is exactly, well, I wouldn't say the opposite, I guess. It's a little bit different than that. So non-conservative forces do work to either increase or decrease mechanical energy. Do work to increase or decrease mechanical energy. So the classic example of this is friction, right? Friction always does negative work, and friction always reduces mechanical energy. Friction converts mechanical energy into thermal energy. And if it's not mechanical energy anymore, that means the object has lost it, and it causes things to get a little bit warmer, but it doesn't cause them to move faster or get higher. So it's no longer mechanical energy. But another thing that can do non-conservative work, or is a non-conservative force, is you. When you push on a cart to speed it up or pull it up an incline, you are adding energy to the system. It's not conserved, it's transferred from you to the system. So you also can exert a non-conservative force and transfer energy to or from a system. So the law of conservation of energy says that energy is conserved. The total amount doesn't change, but it doesn't mean we can't move it. It doesn't mean we can't change what type it is. So if it's conservative stuff like gravity, or if we had a spring in here, a spring would be doing conservative work. It would just transfer energy from the spring to the cart and then back. That doesn't change the overall amount of mechanical energy, just how it's distributed as kinetic or potential. Non-conservative forces actually reduce the amount of mechanical energy or increase the amount of mechanical energy by adding energy from some other source or converting it to some other form.